Hi, my name is Josh Long. I'm a Spring Developer Advocate, a Java champion, and a YouTuber. I created this course because I want to help people deliver production-worthy systems and services in terms of Spring. In this course, we cover the fundamentals of Spring Boot. We look at data processing, web programming, enterprise integration and messaging. We look at AI, and we look at how to architect your code to be as efficient and scalable as possible. Go forth and build production-worthy, AI-ready, cloud-native production systems and services with Spring. What does Spring Boot do? Well, remember I told you about how there's this configuration mechanism, this convention over configuration. Spring Boot gives you the best of both worlds. It gives you the ability to create as expressive configuration as you want, just as I just did with all those different objects. But it gives you some defaults, some useful defaults. So here, I've got my service, my customer service, right? Just as before, nothing changed there. Got my logging bean post processor, right? And I've got my public static void main Spring Boot application. Where's the database? Where's the schema initialization? Where's most of it, right? All that code I deleted. I don't need it anymore. So if you go back to the test, the test also gets a little bit easier because now I can use Spring Boot test instead of using Spring JUnit config. And so the same, basically, and also I'm using this nice extension to capture the output. This is standard out, and I can do assertions against the output there, right? So let's start the Spring Boot application. And you can see the Spring Boot application has, very importantly, very good ASCII artwork. Banner ASCII artwork is key to successful production deployments. It also has my everything else, the shutting down customer service, the logability, all that kind of stuff. Okay, so everything is the same as before, but I wrote much less code. And the reason that's true is because I have auto configuration. Okay, why is this Well, the auto configuration is the key to Spring Boot. This is why it's so consistent in large organizations and small. If you want to get something up and running out the door in as few lines as possible, there's nothing more concise than your typical Spring Boot application, right? Like I built an application that talks to a SQL database, has observability, is production worthy, has a container, and I just starts out Spring.io and I wrote 6 lines of code or whatever it was earlier, right? 10 lines of code. It's very, very concise, but it scales. That's the difference. That consistency scales, and the way it scales is through this thing called auto configuration. And the auto configuration works when Spring Boot starts up. It looks on the class path and it finds this text file called spring.factories. Okay, this is what makes Spring Boot, and everything else Spring Framework. So you look for spring.factories. This is a service loader. Okay, Spring will find this class in the meta-inf directory of your code. Where's my? Go over here. There, meta-inf spring.factories. It'll find this class, and it'll find a key followed by a comma delimited list of class names. And these keys get used for different lifecycle pieces. There's another file that it looks for called autoconfiguration.imports. Okay? .imports. And this file lives in Spring Boot jars. So you can see this one lives in meta-inf/spring/org.springframework.boot.autoconfigure.autoconfiguration.imports. That's a text file. The name of the file is called autoconfiguration.imports, right? It's called org spring framework boot autoconfigure.autoconfiguration.imports. And it's just a long list of Java classes. These classes get evaluated when the program starts up. So if you look at Rabbit autoconfiguration for RabbitMQ, right? You can see it's got a lot of red here, right? This Rabbit autoconfiguration is a configuration class. It defines a bunch of objects, but it has these conditions. This condition says, run the Rabbit autoconfiguration, but only if there is a Rabbit template.class on the class path, and only if channel.class is on the class path. It's like an if-def macro in C, right? But it's happening at runtime. It's when the program starts up. So we add the body of this configuration to all the objects that are in play, but only if this type is on the class path, if the library is on the class path. If it's not there, then don't bother, because we would surely get a no class def error or a class not found exception or something like that, right? So this is very, very dynamic. What it means is that if you want to have a default experience, you go to start.spring.io, you choose some of those starters, right? Those checkboxes that I showed you earlier, those over here, right? If I go here, if I choose web, that Spring Web is going to give me Spring Boot Starter Web. That's a starter. These starters are packaged with auto configuration. You just add that to the class path, and it automatically runs a web server for you and it installs Spring MVC for you, and it sets up the servlet stack, and it installs JSON marshalling and XML marshalling and form handling, just by the presence of the build. I've done nothing to the code, right? Nothing has changed to get all of that. And that's because of the presence of these auto-configured starters. That's very, very powerful. Now I think it's time to build up a simple sort of HTTP controller, our own service based on that. And we've already seen some of this so far. We've looked at Spring MVC so far, but let's just rehash that point here. Class users controller. I'm going to inject the declarative user client, right? Okay. Add that to the constructor, and I'll just create an endpoint here called users. And this feels like a bit of a waste, but okay. I'm going to just call the client. It in turn is going to call the other service. And by the way, since I am calling another service, what's the first thing I should do? Virtual threads.enabled is true. Always remember, do that first. Okay. We don't need to rerun that code that prints things out. Okay. So localhost 8080 users. There we go. So this is my service, which in turn is calling the other actual service and getting all the data back. It's a bit of a silly example, but you can see how easy it is to do that. So I'm making an HTTP GET request. You know how you can tell? It's because it says GET request or GET mapping. Okay. Now, obviously, if you're doing an HTTP post, you can do post mapping. You get the idea, right? And there's all sorts of create user. I can have a request parameter here, right? Request parameter string name. I can do a path variable, int ID, and then that means I have to have it in a template there as well. Okay. You can get access to the underlying raw HTTP servlet request, right? Servlet request, if you want. Just inject that as a parameter. So these parameters, you can decorate your controller methods with as many parameters as you want for all these different kinds of verbs. Their lowest level annotation is actually request mapping. Request mapping, in turn, has a field called method. So this is semantically equivalent to this. These two are the same. Okay. One is just a stereotype, a meta annotation for the other. What I'm going to do is I'm going to use the Spring Framework application event publisher, which we've looked at before, and we're going to publish an event. Okay, I'm going to publish an event from the adoption service to the dog-tour module. Okay, so I'm going to create my first purposefully public type, dog adoption event. Okay, public, and it's going to have the dog ID. Okay, and that's my first type that I've intentionally made public. I'm now going to go back over here to my my service, and I'll say application event publisher dot publish new dog adoption event. Okay, so now that that's public, the event is public, I can go back to the dog tour and just turn it into a listener for that event, right? So event listener dog adoption event. Now, of course, because that's public, these don't need to be anymore, right? These can be packaged private again, which is nice. So let's see. Actually, that should just run. Here we go. Okay, run that. Command 5. There you go, scheduling. And we can see scheduling for the dog adoption event, not the int that I had before. So it's worked. I've got these two modules integrated with each other. They're talking to each other, but they're decoupled. One doesn't know about the other. They don't need to know about each other. Except they're kind of coupled, aren't they? Remember, we talked about how you can publish events from one module to another. Those events are published synchronously in the same thread. So if I go over here and I say thread.sleep throws exception, right? Because thread.sleep throws an exception. And then I run the same request. Notice that even though I'm calling the dog adoption service, it's not returning. There you go. It took 5 seconds to get that response. Because another component in the system, somewhere else that I have no idea about, did a thread.sleep, right? Can you imagine how frustrating that would be to debug? I'm working on the adoption code, and for some reason, now somewhere along the lines where there wasn't an issue, now there's a 5-second delay. Somebody added something that took a long time, and I have to wait for it. My SLA is in trouble. So this is not what you want when you want messaging, right? A lot of people think about asynchronous fire and forget. And you can get that after a fashion, right? It's pretty easy in Spring to, and by the way, a service is just a component, remember? It's a meta annotation, so I'm using service because it makes it clear what it is. I could get asynchronicity, right? I could just make it at async like that. And what that does is it wraps the invocation in a thread and then launches the thread. So I publish that message, returns immediately, right? And then 5 seconds later, you'll see it print out scheduling, right? So now it's invoking that method in a separate thread, but now I've got the risk of losing state, don't I? Right? Because imagine if I got the adoption thing, I'm updating the database table. That's happening one transaction. I publish the message, it goes to another module, and it gets to the dog tour. That runs for 5 seconds, and then before the 5 seconds lapses, somebody pulls the power out of the machine. Transaction lost, right? I've got my system in an inconsistent state, right? Which we want to avoid. So how do we get the best of both worlds? How can we have our asynchronous, fire and forget cake and eat it too? Well, we can use the outbox pattern, okay? So Spring Module to the rescue here. We're going to use a application module listener. This pairs like fine wine with cheese with this property here. Say, initialize the schema, and Modulith republish outstanding events on restart. Okay, this is the important bit. Okay, and then go over here. So I'm going to publish it again. It's instantaneous. It returns instantly. So it's still asynchronous. Wait for it to finish. Good. And now you go over here, refresh the tables. We have this new table called event publication. Okay, and this event publication table has the ID, has the listener ID, has the event type, the serialized representation of the event, the publication date, and the completion date. So let's try this again. Refresh. Notice that there's no completion date yet, right? I'm waiting. Refresh. There it is. Okay? So that completion date only gets filled in once the event listener has been dispatched and completed successfully. So what happens if I don't complete something successfully? Publish. Stop the Java process. Okay? Refresh that. You'll see that there's null, and there's no chance of it ever becoming non-null until something happens. I'm going to restart the JVM now, and you can see that missed message was asynchronously redelivered and reprocessed. And so that happened on restart. Okay, so this is the outbox pattern. You use the outbox pattern to reconcile non-transactional state against a transactional ledger. In this case, a SQL table.